Hi all, welcome. I'm Yunus. In this short video, we'll talk about embeddings in large language models, which is a very important topic in Gen AI. As you know, AI models cannot understand text, it can only understand numbers. So we need to convert the text into a numerical representation which can capture its meaning, its context, and the relationship between words. So when we talk about embeddings, we'll try to understand how this process works. Okay, let's start. As you already know, Gen AI is powered by large language models or LLMs. LLMs actually take a huge amount of text. Literally, it eats up the complete internet pages as input and then it trains itself on that input. Basically what it does is it goes through the text and try to make sense of each word, the semantic meaning of each word, the relationship between words and the context in which these words are used. And then it converts these words into numerical representation because AI models cannot understand text, it can understand only numbers. So it actually converts the text into numerical representation. Now to capture all the properties of the text, the semantic meaning, the relationship between multiple words, the context, etc., one single number is not sufficient. So it actually uses a sequence of numbers, which means it has multiple dimensions. The numerical representation of each word will have multiple dimensions. So it is called a vector. Now let us see an example vector. This is just an example just to explain the concept because actual Gen AI model will have thousands of dimensions for each word. Here I am taking only 5 dimensions. You can see I am asking whether it is a fruit or not. I have only 4 words: apple, tomato, football and rugby ball. And I am asking a question, is it fruit or not? If it is fruit, I am giving 1, otherwise -1. Then price in dollars, 4, 1.2, etc. Color. For each color I have given a number representation. So if it is red, it is 4, white 7, etc. Shape, if it is pure round, maybe I will give 4, but if it is just roundish, I will give 3.2, 3.3, etc. Weight in kilogram. So with this, we can actually represent an apple something like 1, 4, 4, 3.2, 0.3. But in real Gen AI models, just having 5 dimensions is not sufficient to capture the complete properties of a word. DeepSeek is actually using 2048 dimensions to represent each word. And at the end of this video, we are doing a hands-on exercise where I will use Amazon Titan text embeddings model to convert a word into its vector. It is actually having 1024 dimensions. We will see that. Now, when you are creating the embeddings or the word vectors, these vectors are designed or created in such a fashion that words with similar meanings or words which are used in similar context will have similar vectors. For example, hen, duck, or all the birds will have similar vectors, or all the pets may have similar vectors. Dog and wolf, because they are similar species, they will have similar vectors. Like that, all the fruits will be similar, all the companies will be similar, or all the country names will be similar, etc. The distance between the vectors actually represents the semantic similarity. So that you would have already got it from what I explained. And another important point is the word vector has to capture the relationships between the words. For example, father, mother, two related words. Father, daughter, or father, son, or cat, kitten, or dog, puppy, king, queen, man, woman. So all these are related. Those relationships also need to be captured. So here we are trying to look at this example. Because of the way Gen AI try to understand the words, arithmetic operations are possible on this. Now look at this. You can say king minus man plus woman equal to queen. So in real life you can't do this, but the way large language model try to understand this, you can take it like this. King means a man with additional powers. So king minus man means now only additional powers remains, man is gone. Then additional powers plus woman. So you are adding those additional powers to a woman and she becomes a queen. This logic works in LLM because LLM is trying to find a way to understand this relationship between words. So that's why it is like this. So if you are doing this calculation, king minus man, 0.8 minus 0.8 plus woman, 0.7. So you can see it has become queen. And then 0.2 minus 0.1 plus 0.2, it becomes 0.3. 0.1 minus 0.9 plus 0.9, it becomes 0.1. So this is how the arithmetic of word works. Now think about a scenario where you are saying I was sitting at the river bank, or you are saying I deposited some money in the bank. So you know that I have used the same word, but it has 2 different meanings. So the same word with 2 different meanings will have different vector representations. And in this example, I am taking fish as an example. The word fish may appear when you talk about ocean, when you have a document about cat, because a cat eats fish, right? Fish may appear there. Fish may appear when you talk about restaurants. the word is same, the meaning is same, but still the context is different, so it will use different vectors to represent fish in these three different contexts. In English language there are some 250,000 words, but to represent those 250,000 words in large language model, it may require some millions of vectors, because each word can be used in 100 different contexts, and LLM need to understand each of those words in each of those separate contexts. That's how it works. Now, what happens when you are asking a query to Gemini or ChatGPT, etc.? When you are using your GenAI tool, first thing is it will actually convert your question or prompt into the corresponding vector. And then it will look for similar vectors, or it is called the meaning fingerprint, right? If I have asked a question about kittens, what do kittens like to eat? It will not be looking for the word kitten, but it will convert that into a vector, and then it will look for also similar vectors. So it will actually look for cat, it will look for pet, cat food, different cat breeds, all those words. Finally, it will end up finding documents with all those words. Then what it does is it will retrieve the information from all these documents which talk about cat, which talk about cat food, which talk about cat breeds, which talk about pets, etc. It will retrieve all those information as context for this query, and it will send your original question plus this context information to the large language model. Now, large language model will analyze your question plus all the available information and start framing the answer. In traditional search, actually it directly searches for the keywords. For example, if you are searching for car, it will only search for car. It will not search for automobile, vehicle, etc. But in vector search, what happens is if you are asking a question about car, it finds similar vectors. Vehicle will have a similar vector, automobile will have a similar vector, transportation also will be somewhere nearby. So it will look for documents with all these vectors and then retrieve the information from all those documents and add as a context along with your prompt or along with your question. Now let us have a quick quiz. There is only one question. In the context of LLMs, what are the embeddings primarily used for? Okay, what is the use of embeddings? Is it to make text files smaller in size? Definitely not. Is it to represent the meaning of words? Yeah, looks like okay. Or is it to translate text between different languages? No. Is it to improve the spelling and grammar? Definitely not. So looks like the answer is B, to represent the meaning of words as numerical vectors. Now, let us do a quick hands-on exercise. I'm going to use AWS Cloud for this. I'll use two services, Lambda and Amazon Titan. People who are familiar with AWS will know what are these, but for others, Lambda is a computing platform where I can write my code and then run the code. I have already written my code in Python. And Amazon Titan is the foundation model which is developed by Amazon. Basically, Amazon Titan has various foundation models for text generation, then image generation, then creating embeddings. So what I'm going to do here is run a program which will take a word as input. Any word, you can input a word like computer, or you can give a pen as the input, whatever a word, and it will invoke Amazon Titan text embeddings model, and it will convert that into the corresponding word vector or corresponding embedding it will find. Okay, let's start with the hands-on exercise. Okay, now we are in Lambda, and I have already created a Lambda function called demo vector embeddings. So let me click on that. So we are in this Lambda function, which is nothing but a program written in Python language. So if you come down, you can look at the code. It's a very simple code, just 40 plus lines. So I'll just quickly tell you the important points. We are going to use a foundation model, and model ID is Amazon Titan embed text. It actually creates the embeddings or creates the word vector. So if you go to your Amazon Bedrock, you can see Titan text embeddings v2. That's what we are going to use. And then input text. Here I'm saying, hi, what is the cost of Honda City? So instead of that, I'm going to just enter one word, which is coconut. How it is going to represent coconut? How many numbers are required to represent it? Basically, this model actually uses 1024 numbers. Let us see that. So that is the input text, and request. You can see that it is actually invoking this model here, and then it is giving some log messages out. That is okay. That's it. It is a simple Python program. Now I have updated the code. So what I have to do is I have to deploy it. So let me deploy that. updating the function demo vector. So it is successfully deployed. Next, I have to test it. So let me click on test. So let me test it by clicking on this. So here the result will come. So it says executing function succeeded. Okay. So I can go to CloudWatch logs. Here there are 6 log groups, but because I executed this lambda function, a 7th one will get created. If I refresh it, it will appear. Yeah, 7. So where is my demo vector embeddings? Click on that and come down. Okay, take the latest one, which is this one, 616. This is UTC time. Okay, so click on this. So remember, the input word is coconut. So your input, it says your input is coconut. Size of the generated embedding 1024. Just open that. Just open the embedding. Here is the embedding. You can see that these numbers, okay, each number is some 20 digits. Like that, there are 1024 numbers to represent one single word, coconut. For a simple word like coconut, it has actually converted that to a number sequence or a vector with 1024 20-digit numbers, so that it can capture the complete meaning, word relationships, and the context of that particular word. Okay, I hope you enjoyed this lesson. Thank you very much for listening to me. Thank you. Bye.